Hey guys, and welcome to another one of my videos. So in this tutorial, I'll be showing you how to set up these player outlines. So as you can see here, they're multicolored, so I have green ones for teammates and red ones for enemies. And I also have this yellow one over here for things like objectives. So I've seen a few tutorials online on how to do this, and I did watch a couple of them to kind of figure out how to get started with this. But in this tutorial, I've made some improvements. Um, some things that I had issues with in other tutorials were shaking, where the outline would kind of jitter and shake. And I also had issues of getting multiple different colors working and also blending issues with particle effects. So I've kind of figured out a way to fix all of those different things. And I finally came up with this result and I thought, hey, I'm going to go ahead and make a tutorial on how to do this. So this is essentially the end result. Um, you can configure the colors. I'll show you real quick just before we jump into it. So you're basically going to have this material, and you can set like the ally team color, the enemy team color, the objective team color, and you can even add more colors if you want. And then you can obviously change these colors, and you can change the line thickness. And obviously you can use the colors for other things besides the ally team or the enemy team. These are just examples that I used because I thought that'd be a pretty common thing that you'd want to use. Um, so yeah, with that being said, let's go ahead and jump right into it. Um, I'm using, let's see which engine version. I'm on 5.0.3, so go ahead and launch whatever engine version you're on. And then we want to select games, and then we're going to use the third person template. And then I'm just going to call this player outlines, and then hit create. So here we just have a fresh third person template project up and running. So first thing I want to do is start working on our outline material. So let's go ahead and right click, and we'll just make a new folder for this, and we'll call it outlines. And then inside of here, we want to right click again and select material and call it m underscore outlines. And then let's open this up and start working on it. So the first thing I want to do is make sure you have this selected. And then in the details panel, you want to search for the material domain here, and we want to switch it to post process. So switching it to post process will basically just allow us, as it says, to use it in the custom post process pass, which is exactly what we want. So let's just start out simple here, and we're going to right click and search for scene texture and select this guy. And we want to switch the scene texture ID to the post process input 0. And then we want to mask this color to be or I think it's called component mask. Yeah, component mask. And we want to mask it to the RGB. And then we're going to hook that up to the emissive color. So if we hit apply and save, let me just go back and test this in our scene to make sure everything's set up correctly, first of all. So come back to your scene and then just select any object. It doesn't really matter which one. And in the details panel, or sorry, before we do that, let's search for a post-process volume. So if you already have one in your scene, which you will if you're using the third-person template, then click on it over here. Otherwise, you can add one to the scene just by dragging and dropping a post-process volume in like so. But I'm not going to do that since I already have one. But anyways, click on the post-process volume and then details panel, search for post-process materials. And you should see right here we have an array. We want to add a new material to the array. And then this drop down, you have to select asset reference. And then in this drop down, we can select the one we just made. So we'll call it m underscore outlines. And now you can see it's actually using our post-processing material. But the reason you don't see anything is because all we're doing inside of the post-process material is we're just returning the scene color, essentially. So if we were to hold down 3 here to create a constant and hook that up to black and hit apply and save, if we come back here now, you can see since our post-process material is just returning black, the entire scene is black. So we can do this as a test just to make sure we're actually using it correctly. So make sure that's all working, and then we can delete this. And now we can start working on the outlines. So I'm just going to add a little comment here and say this is the normal scene color. Because for most of the scene, we want to use the normal scene color, but for the other parts where we want to do the outline, we obviously want to use a different color like red or green or whichever we choose. Okay, so let's see here what to do first. So let's start with the edge detection to figure out where the outlines are. So somewhere over here, right click, or sorry, hold down 1 and left click, and that'll create us a scalar value. And then you can right click on this and say convert to parameter. And we're going to call this the thickness. So this way you can configure how thick the lines are. And then we're going to use something called blur sample offsets. And I'll explain this once we get it a little bit more going. But we're going to be using this, and then that's going to allow us to kind of sample the pixels around the current pixel. And so in order to do that, we need to first get the color of the current pixel. So to do that, we can right click and say screen position. And we want to take these UVs and we want to mask. So component mask, just the R and the G channel. And then again, we want to use this scene texture node. So search for scene texture, except this time we want to use the custom stencil. And then hook this up. And then for the color, we're going to actually do 1 minus, and then we're going to take this and multiply it by a -4. So the reason we're going to multiply this by a -4 is basically because we're sampling the color in the stencil buffer, which we're going to use here in a second, and we're going to multiply that by -4. And then what we're going to do is we're going to sample 4 pixels around that pixel, and we're going to add the colors to the center pixel color. So let's say if we sample a white pixel, we're going to multiply that white color, which is 1, by -4. So we're going to get -4. And then we're going to add each pixel around it. So each pixel around it is going to be 1. So it's going to be -4 plus 1 plus 1 plus 1 plus 1, which is going to give us 0. And once we get 0, we're going to say, okay, this pixel, all the pixels around it are the same color. Therefore, it's not an edge. Therefore, we don't need to do an outline. So that's kind of the idea here. I know it's kind of confusing, but I'll try to explain it as we go along. So this is our center pixel. So just add a comment, say center pixel. And like I said, we want to do the 4 different samples around that pixel. And that's what this is for. So this actually gives you 8. This is the one above it, to the right, below, to the left. And then these are kind of that diagonals. We're actually not going to use these. You can if you want to use these as well. You can do 8 samples, but I think it's kind of overkill. So essentially, we're going to do the same thing for each of these. So we want to start with the something called the scene texel size. So the scene texel size is, well, you can just read it there. If you hold down Control Alt, it'll let you read what it does, but it basically helps for games that have different resolutions. The outlines will remain consistent regardless of the resolution. And then we want to multiply this by our right side, which is 0, 1, or I think that's up actually. And then we want to take this and we want to multiply it by our center position. Or sorry, we want to add to it our center position. So we'll say add, and then we'll copy this guy up here because this is our center screen position. So just copy those both those nodes and hook that up like so. And then from there, we want to use this. Actually, we can just copy it from here. We want to use this guy again. Copy, paste, hook that up to the UVs. And then we're going to do 1 minus this again. So 1 minus. And then that's basically what we're going to do for each of these. So I would try to make this kind of condensed since we're going to copy and paste it here in a second. Just try to get it just looking a little nicer. Let's see over here. Here, like so. Okay. And then once you have all this, make sure this is correct. And then copy this, paste 1 time, 2 times, and 3 times. All right, so we should have 4 of these. And then what we want to do is we want to drag these values over in order into the multiplies. So this is where we're doing the sampling of all the pixels around the center pixel. And so like I said before, we're going to add these to this value, and that's going to tell us whether or not this pixel is on the edge of something we care about. And so we can change the color of the pixel to be, red or green to make it appear as if there's an outline. So we want to take all these and we want to add them together. So we're just going to add this guy to this guy, and then we'll add these two together. And then we want to add these two together. And finally, we want to add these two together, like so. All right. And then we want to take this value and we want to floor it. And then we want to take this value and we want to clamp it between 0 and 1 because that's really all we care about. And then finally, we want to mask this, so component mask, and we only want the R value. Okay, so now that we have this, I'll put it here so you can copy it or make sure yours is good. What we're going to do is let's just output this real quick so we can kind of see what's going on here. So let's output this to the opacity color. So we hit apply and save, and we come back to our scene. You should see black again because currently we're not writing anything out to our stencil buffer. So if you remember, we did some stuff over here with the custom stencil buffer. So in order for this material to actually work, we're gonna have to write out the objects in our scene that we want to have outlines around them to the stencil buffer. So if we go back to our scene here, and then let's just switch this to unlit real quick, just so we can actually see what we're clicking on. And let's click on this box here, and in the details panel, search for, I think it's custom, maybe depth, I forget what it's called. Yeah, depth. And we have these options here. So we want to check render custom depth pass. We want to make sure that's true. And we want to switch the custom depth stencil value to 1. And then now if we go back to our lit mode, okay, well, we see nothing. So I forgot to do a couple things. So first of all, we want to come back here to our project settings. So we're going to edit project settings and search for custom depth. So we want to make sure that our custom depth stencil pass is set to enabled with stencil. And then we want to make sure we uncheck this. So if you don't uncheck this, you're going to have that jitter that I was talking about. It even says jitter right here. So make sure this is unchecked. And then we also want to go back to our material and we need to set our thickness to something. So let's just give it a default value of 1. So now if we come back to our scene here, and where is our box? Let me switch this back to unlit. Okay, we have our box here. Set this to 1 again, and then lit. Oh, did I not hit apply? Yeah, make sure you hit apply and then save. And there we go. So now we can see a simple white outline around our box. And this is essentially the foundation of our outline and where it's going to start. But there's some problems with it right now. Like, first of all, well, obviously it's not the correct color, and the scene is still totally black. And it also can be seen through walls. So we're basically just going to be fixing each of those problems one at a time. But make sure this is happening for you. And if it is, then you know you're on the right track. Okay, so now we have the basic outline going. So the next thing we want to do is we want to start adding in these colors. So I'm actually going to take all of this and I'm going to move it down here. We'll add a comment around it and just call it like the outlines because that's essentially what it's doing. And then the next thing we want to do is we want to make use of this value that gets passed in here, because realize we passed in 1, we could pass in 2. It doesn't really matter what we pass in here. Obviously, you pass in 0, you're not going to see anything. But if it's any value above 1, you're going to see something. And you can actually view this depth buff or this this stencil buffer that we're writing to. If you go to lit, this is just a neat thing, and you go to buffer visualization, and you look for the, I think it's custom stencils when we want. There you go. So this is actually using Unreal's shader. This is no longer using our material anymore. This is using one of Unreal's materials that renders the values that are being written to the stencil buffer. So this is actually a material behind the scenes that gets rendered to, and you can obviously render to it whatever you want. We're using it for outlines, but you can see it's just chose yellow as the color for 1. But if we select this cube and switch it to a different color, you can see it actually changes the color. And again, it's just choosing a random color. So it can show different ones. And then it has 2 here to show you which one. And if we selected something else, like the floor, we said, hey, render this to the stencil buffer as well. And we said, give this a value of 1. You can see basically rendering, it's re-rendering our whole scene, but it's just rendering out essentially 1, 2, 3, or some value to represent that, and then it's just kind of choosing a color to represent it in this buffer. But that's neither here and there. That's just something interesting if you cared about that. Anyways, let's switch this back to lit so we can work on our material. And then we want to make use of those bits, those 1, 2 values, to switch the color. So right click and search again for scene texture. And then this one, we want to switch again to custom stencil. And then we want to mask the color. So component mask, we just care about the R value, because again, these aren't like color values, these are just 1, 2, 3 values. And then we're actually going to take this and divide it by 255, because the masks go from 0 to 255. So in order to convert it to 0 to 1, we need to divide it by 255. And then we're going to use the bit mask function. And the bit mask is this guy here. And then the bit, we're just going to hold down 1 and left click to create a scalar, hook this up. And we're going to change this value to 1. So we're basically saying anything that has 1 inside of the stencil buffer, go ahead and use this value. So we're going to hook up a color to this value. And then we can do this for other colors as well. So if you actually take this, copy and paste it here, we can make another color and tie it to 2. So if we change this to 2, we'll have 2 colors. And we can do it again if we want to have a third color. Just make this 3. So you can do this as many times as you want, up to 255, because that's the max value of this color. So you could technically have 255 different colored outlines in your game if you really wanted to. But for this tutorial, we're just going to stick with 3. And then, like I said, we want to hook these up to colors. So let's start up here, hold down 3, left click, and this is just going to be our base color of black. And we want to lerp this. We'll say lerp. I think it's called linear. How do you do this? Linear interpolate. Yeah, you have to type out linear interpolate, but then it just shows up as lerp. It's a little confusing. And then here we're going to put our 3 different colors that we want. So again, let's hold down 3 and left click, and then convert this to a parameter. And you can call this whatever you want. Like you could call it color 1, color 2, color 3, or you could give it a more specific name. It's basically whatever this color represents when you pass in 1 to the stencil buffer. So I'm just going to call this the ally team color like I had in my example. And then you can just leave it black because we're going to be overriding it in the material instance. But anyways, you can copy and paste this to create another one, and then call this the enemy team color. So again, these values are going to get tied to these 1, 2, and 3. So if you have 3 values here, you want to have 3 values here, not counting this top one, because this top one's just the base color. So 1 is going to be our ally team color, 2 is going to be our enemy team color, and then we'll have 1 more just as an example. Like maybe it's a objective color, maybe they have different colors in your game or whatever. But that's basically the idea here. It's obviously going to change based on how you want to have it set up, but you just want to lerp all these together. So you're going to drag this into the B, and then the alpha is going to be this top value here, so that there. And then we're going to do this for each one of these. So we're going to then take this. I'm just going to copy this node. I think we need it 2 more times. And so the A's are always just going to go in like this. And then for the B, it's going to be this guy and this guy. And then the alphas, we just want to hook up like so. Hopefully you can see the pattern here. It's pretty straightforward, but it's just we're combining all these colors together. And then from there, we want to take this value and let's actually fix it so our scene doesn't look totally black. So let me try to get this organized here. Hold on. I'm just going to move this back a little bit to the left so I have some room. And we'll put this back here. All right, so we want to take this color value from our normal scene, and we want to do another linear interpolate. And the A value should be connected like so. The B value is going to be from this guy that we just created. So, sorry, I know I'm moving this around a lot. I'm trying to get it somewhat organized. So A value comes in from our normal scene color. The B value is from the chain of lerps that we just did. And then the alpha is going to be this emissive color. So this again comes down from here. So this is what it looks like right now. It's hard to get everything on the whole screen at once. Hopefully you can follow along. And then this is going to finally hook up to our emissive color. So now if we hit apply, wait, what is my error? Oh, right. So we need to make sure we hook these up to the color as well and hit apply and save again. And then let's go back to our scene. Okay, so now we have our scene back. And you can see that this cube now has a black outline around it. And that's because our colors are all black here. So in order to fix that, we're now going to create a material instance off of this. So right click on this guy and say create material instance. We'll call it MI for material instance underscore outlines. And then open this up. And here we have all of our values. So we can check thickness, ally, enemy, objective, and like so on. So we'll say the ally color is green, the enemy color is red, or orange, I guess, and the objective color is maybe some blue color, right? And so now, if we come back to our scene and we go to our post-process volume, if we search for that material again, post-process material, we can now switch this out for our MI underscore outline, which has our color values in it. And there you go. You can see it changed it to our orange/red color. And that's going to change based on what values you have in for the custom depth stencil value. So you can see if I switch it to 1 and then I unselect it, so you can see it switches it to green. If I switch it to 2, it goes to red. If I switch it to 3, it goes to that blue color, which is kind of hard to see because this thing's already blue. But it's basically working, right? So that's how we can change the colors. Now, the only thing we might want to fix, depending on your game, is the ability to see them through walls, right? So you might want this behavior if you're doing like a spectator system, or you might not want this behavior, right? Because obviously you don't want to be able to see enemies through walls. So I'm going to show you how to fix this, and then you can optionally do it in your material if you want, depending on your game. So basically, we just want to return this normal scene color if the object we're looking at is behind a wall, right? And we can't actually see it. So to do that, we can make use of the depth buffer, because that keeps track of how far things are away from each other. So first of all, we want to get our scene texture again for our custom depth buffer. So switch this and search for custom depth. And then we want to mask this value out, just the R channel. And we want to compare this to the scene depth. So right click and say scene depth. And if we want to mask this guy out as well, for just the R value. And then we actually want to compare these, like I said. So we'll do an if, why can't I type if? There we go, if. So we want to compare this one to this one. And so we want to say if the custom depth is greater than or equal to the scene depth, then we want to use 0. And we're going to say that's basically going to make it so that if this cube is behind a wall, it's going to use the color of the wall in front of it. Otherwise, it's going to use the color of the outline. So let's just make 2 scalar values here. And we'll change the second one to 1. And so 0 is going to hook up to the greater than or equal. And then 1 is going to go into the less than. And then we want to take this value and, we want to take this value and multiply it by whatever value comes from down here. So I'm going to control drag this like so. So just to clarify, this multiply is getting hooked up to all of this outline stuff that we did, like so, just so you can see it. And then this value is going to go into our alpha, like so. Now, if we run this, if we hit apply and save, and we go back to our scene, you'll notice we can't see it through the wall, but it has this like shimmering effect to it. And the reason that's happening is because kind of undecided as to if the pixel here is actually behind the box or in front of the box, because the pixel is actually part of the box. So it's kind of going back and forth as to whether or not it thinks this box is hidden. So in order to fix that, what you can do is just take this top value here, and before we do the if, we can just subtract a very small number from it, and that will fix any sort of um, slight issues where it's not sure. So I just settled on 10 for my project. Um, you can maybe play around with this number if you want, but this seems to work very well. You'll never see it through a wall because a wall is never going to be that thin, but it fixes any sort of issue. So now you can see if we kind of have it half behind a wall, you can't see it. And just to prove that it works correctly, if I drag it over here, you can see the outlines stop as soon as it gets to the wall, and everything works fine. Okay, and then if you don't want that, obviously you can just leave it as it was before. So I'll just add a little comment around here, and this is the part for the all outlines that are behind walls. And so that's kind of an optional thing. All right, so the next things we want to do here should be pretty quick. We basically just want to make it so that the outlines can be given to players in like a networking scenario. If you have multiple players, you can have your teammates be green and the enemies be red, for example. And I also want to take it so that this post-process volume is not part of the level, it's actually part of the player. And so that way, if you were to switch levels or load a different level, the outlines would just work and you wouldn't have to worry about adding a post-process volume with these settings to every single level, because that could get annoying. So we're going to go over that in part 2. So I'll see you guys in part 2.